This is a renovation project, the Atlantic West Elementary School in Broward County, Florida, the largest school district in the country. To access the power distribution system in this building, click on the control panel in the upper ribbon, black ribbon. What you can see here now is the entire power distribution system for that building, which consists of the MDP, the main distribution panel, several of the distribution panels in gray, and then below in blue is going to be the lighting and power panels. And if we scroll down a little bit, you're going to see most of the major building equipment associated with the school. It has 2 chillers, a couple of pumps, an air compressor, and so forth. How did we get there? By clicking on one of the panels and then enter the control panel of the MDP, you find some of the functionality associated with the MDP. So one of the most important functions that we have established with the program is the wizard. There are 3 wizards associated with MDP. One is the wizard to set up the panel. The second one is for the branch circuit inputs, and the third one is the erase wizard. Perhaps the most important wizard is the branch circuit inputs. This is where you go to input the 3 inputs associated with each of the branch circuit for the system to start calculating all the values associated with the branch circuit and the feeders. Here we're looking at the branch circuit wizard. Let's look at the inputs required for each of the branch circuits. These inputs are load kVA, number of poles, select load type from the pull-down menu, which has several load types from the AC to lighting and receptacles and more loads. Now, if you scroll circuit by circuit, you can see that we have already input some values associated with this particular panel MDP. Right now, we're looking at circuit number 2 with the load description of lighting, and the load kVA is 392. You can go ahead and keep on going circuit by circuit until you're done with this particular panel. Then close and calculate. Now let's see the simultaneous generation of the electrical design on the one-line diagram. By clicking the one-line diagram button, this is the entire one-line diagram. The entire one-line diagram is automatically generated at the same time with each and every input. Let's look at the entire power distribution system for our school, the Atlantic West Elementary School. You can see here at the top is main distribution panel, and then the power flow downstream to each of the distribution panels and the panel boards and to the equipment as was designed. The power flow from the top to the bottom, which is the opposite of our concept in developing the one-line diagram. When we develop the one-line diagram, we develop it from the bottom up. We started from the branch circuit panels and build it up all the way until we got to the main distribution panel. Let's take a specific circuit to talk about it a little bit. Let's take circuit that's going to the chiller, which is circuit number 1 in panel CH, as you can see. Now, when you look at the chiller, it has a circle with a number 13, which designates the size of the conductor. On the left side of the one-line diagram, you see a chart or a table with the conductor sizes associated with these tag numbers. So if you go to number 13, that feeder for the chiller is a 1 set of 3 number 3 and a number 10 ground in 1 1/4 inch conduit. All right, let's go back to the power distribution network. Clicking on the tab, you can see the power distribution network associated with the one-line diagram. If you remember, the circuit that we were looking at was the circuit to chiller and was fed from panel CH. So if we scroll down a little bit, we'll find panel CH. So we're going to go and enter open panel CH, and then we see that the circuit associated with the chiller is circuit number 1. And here's the chiller. And here is the overcurrent protection device associated with that chiller to safely protect it and safely operate. And then the conductor size that we talked about, number 3 and a number 10 ground and 1¼ inch conduit. To go back to the power distribution network, click on the control panel. Here's again the power distribution network. If we scroll down, we can see the chiller. So if I click on the chiller, it would take me to the data sheet associated with that particular chiller. And it will say that the chiller, or will indicate that the chiller is fed from panel CH1, and here's the load associated with it, and then the NEC calculation associated with that particular load. Let's say that we decided to change where that chiller is fed from. So all we need to do is to go to the tab titled Fed From, scroll down, delete that circuit, and now we're going to go ahead and say connected to panel EM. Here it is. It would show me the available circuits to connect that piece of equipment. It's circuit number 2, 3, 4, 5, and 6. I can go ahead and select any of these circuits. Let's say it's circuit number 2 and submit. So now that chiller is fed from EM circuit number 2. If I click on the fed from, it will take me to that panel EM, and if we scroll to the right, we will see that the chiller has moved to circuit number 2 on panel EM. Now let's go and see if that change took place on the one-line diagram. To do that, go back to the control panel, scroll up, click on the one line, and go to panel EM, and here's our chiller. And of course the feeder number have changed from a number 13 to number 15. So the chiller used to be fed from panel CH, it was taken out, and now we only have pump is fed from panel CH, and we see that the chiller moved to panel EM automatically. You didn't have to draw a line, you didn't have to change any of the values. Now, when that change took place from panel CH to panel EM, everything associated with panel EM upstream all the way to the MDP have also changed for you automatically and redrawn automatically. So again, minimal input, minimal error, and higher quality design.